Now you know that atoms, if we talk about the electronic configurations of atoms, okay? So you know that atoms has three subatomic particles that we call electron, proton, and neutron, okay? And these subatomic particles are present inside the atoms, and how they are being discovered, that we're going to discuss in this chapter, and some of the drawbacks of the some models, okay? So note it down, the first chapter is structure of atom, and write down that atoms is made up of three subatomic particles. Atoms, subatomic particles are electron, proton, and neutron. Please note it down. Done? Done, everyone?
No.
Note it fast. Done? Okay. Now, how this atom is being discovered? Okay, let me tell you that how the electrons are being discovered. So there was a scientist named uh, J.J. Thomson, okay, who did an experiment. This is called cathode ray experiment. And what he does actually, let me show you that he did a cathode ray experiment. Cathode ray. So this was the cathode ray experiment that has
Cathode rays are produced in a
okay, let me show you this one to you. This is the cathode ray experiment, okay? Cathode ray experiment. And what happened in the cathode ray experiment is that J.J. Thomson took metals, okay? And he means he take a glass tube like this, which is called cathode ray glass tube, okay? And he almost removed the air from it. Almost negligible amount of air is there, and which is having very, very low pressure, and this is a vacuum pump, and it helps to remove this portion, okay? Now what happened here is that when he pass electric current through this, okay, it is having very low pressure. The pressure is only 0.0 mm Hg, which is very, very low. According to the normal pressure, normal atmospheric pressure is 760 mm Hg. So it is approximately 1, 2, 3, 4, 10 lakhs times less approximately than the original pressure, okay? Atmospheric pressure. So the almost the all air has been removed from it, and by passing high voltage current, approximately 10 kilovolt. 10 kilovolt means 10,000 volt. So when high voltage current is passed through it, then simply a beam moving from negatively charged rod to positively charged rod is being observed. Okay. So it is being observed that these lines travels in a straight line, and they cast shadow. If an object is placed, the shadow is always made on the opposite side of the light. Okay. So if the light is coming from this direction, the shadow will form in the opposite direction. So this indicates that when we put a heavy metal plate, so it is forming the shadow, indicating that it is coming from negatively charged, because the shadow is formed towards the positively charged rod, so indicating that it is coming from the negatively charged rod. Secondly, if a wheel is placed in the path of this one, of these rays, then it make it to rotate. What does it means? That when it is able to rotate, what does it means? Can you answer me? What does it means if it is able to rotate? It means that the particles are carrying some mass, and because particles can transfer its energy to the another particle. Another particle means another metal, another substances. So if the blade is rotating, it means that some of the energy or some of the momentum from these particles is being transferred to this stationary free wheel, and it is rotating just because of the momentum of the particle that are hitting it. So momentum, the formula of momentum is mass into velocity. If something having mass and velocity, it has momentum. So it means that particle must have some mass, because the moment, if we are transferring its momentum to the stationary wheel and making it to rotate, indicate that these wheels are rotatable. Are you getting my point? समझ आ रहा है? Everyone?
Yes, sir.
So
Yes.
these wheels are rotatable, and they can easily make it to rotate, indicating that the momentum can be transferred. Okay. Moreover, if we want to know the charge, that whether these particles are made up of charged particle or not. So when we bring a positively charged electrode or a negatively charged electrode towards the straight beam, then this beam get diverted towards the positively charged, indicating that these beam particles are negatively charged particles, because negative species is attracted towards the positively charged species, indicating that this is a negatively charged species. Understood? Understood? Yes or no?
Yes.
So we'll simply say that these rays are the cathode rays. If there is another light particles, like photon is a light particle that we are coming from sunlight, and it does not carry any charge. So if these light rays or the light that is coming from the sun, if you place a positive and negatively charged rod towards it, they will not affect it, because these are not the charged particle beam. The charged particle which is carrying charge, the beam which is made up of charged particle, then it will be diverted with the positive and negative electric field. Okay, got it? Otherwise, if you have, let's suppose if you have a laser light, normal laser light that we have in like green color and red color laser light, we usually have as a toy. Okay, so if you pass it and place electric and negative field, then it will not get deviated, because it is not made up of charged particle. So electron beams are made up of charged particles, and they get affected with the positively charged sunlight. Got it?
Yes.
So it is getting deflected. Next is, this indicate that these made, okay. And if you charge particles also affect the magnetic, because you know that magnetic, when a moving charge particle move, it behave like a magnet. Like if you have rotating like in the motor or in the generator, if we rotate a coil in a magnetic field, okay, then it generates the electric current. Or we can say that you can see that a charge particle, or if a electric current is passed through a wire, high voltage electric current is passing through the wire, then it can behave like a magnet. It is a property of charged particle, but then when they move with us in a straight line or in a particular direction, then always it forms a magnetic field. It form magnet. It behave like a magnet. And like in our motor or induction motors or other thing, fan, or that there we use we wind the copper. Okay. And when we wind the coppers in the rotator, then an electric current is passed, then it behave like a magnet. Okay, temporary magnet or electromagnet we called it. Electromagnet means that when we pass electricity, it behave like a magnet. So it is not the property of a conductor. It is the property of a moving charge particle, means electrons. When electrons move, then they behave like a magnet. And you know that a magnetic force can affect the another magnetic force. Means magnets attract each other or repel each other. If North Pole come closer, then it will repel. If North and South come closer, then it attract. So you have already been play in science childhood. You have already been gone through the experiment that it attract and it repel. Magnets attract each other, and if they also repel each other. So simply, when charged particle are moving, then they must have some magnetic field, and a magnetic field can be affected by another magnet. So this beam, which is having another magnetic field, because they are moving charge particle, because they are the electrons particles and they are carrying charge and they are moving charge particle behave like a magnet. So it must exert. If we bring an external magnet through it, so it will affect. Either it will attract each other or it will repel each other. Okay, so it is the property. If we reverse this south pole and we'll give the south pole, then it will bend towards this side because south pole repel. So, so we'll say that if we have a normal light, like a photon, the electric light or the laser beam, it will not get affected with the magnetic field because these beams are not made up of charged particle. They are made up of photon. Photon is also a particle of light. So if the beams are made up of photon and photon do not carry any charge, so no charge means if the particle is moving without charge, it will not show any magnetic field and will not get affected with the bar magnet. But if the electron beams are moving, the charged particles are electrons particles and it is carrying charge. So moving charge particle behave like a magnet. And when they behave like a magnet, so when we bring an external magnet near to it, then it will affect over it. Understood? You got it? समझ आया?
Yes.
So what are the
Yes,
properties
sir.
of dot rays? They move from positive negative to positive terminal. They create shadow in the path, indicating that they are moving from negative to positive because the shadow is formed towards the positive terminal. They can rotate a stationary wheel, indicating that they must have some mass. Mass means because if there is no mass zero means momentum zero. Momentum zero means it is not transferable. But if you hit if you take a stone and you hit another stone, the stone is get destructed. Okay, if you have a stone and you hit another stone through it, then if the stone get disrupted, it means that the stone that you hit has transferred some of its momentum to the another stone which was stationary. Same, if a charged particle having mass hit the another mass particle, so it means it has transferred its momentum to that stationary wheel, indicating and make it rotate, indicating that electrons are mass carriers, means they have mass. Electrons are charged particles or charged particles. It shows that they are negatively charged particle. If we bring a positively charged electrode, they move towards it, indicating that negatively charged particles will always be attracted towards the positive charge. And more second proof of that these are made up of charged particle is that moving charged particle behave like a magnet. And whenever a charged particle moves, then it behave like a magnet. So magnetic force can affect the another magnetic force. So if we bring an external magnet near to it, then it get diverted from its path. Okay, understood?
Yes.
Understood? So draw this diagram, cathode ray experiment, discovery of electron, and then we shall be moving further. Draw this diagram. You done, everyone?
Yes.
Oh. Next. Just a minute. Properties of notarized document. Just a minute. Just a minute. Just a minute. One more minute, okay? Yeah. So you have to start writing the properties of cathode rays. Cathode rays are negatively charged. Okay. So here we have, write down the properties of cathode rays. Properties of cathode rays. Done? Noted?
No.
You done?
No.
You're taking much time.
Done.
Done?
Yes.
Oh, everyone done? Ritvika? Sorry, Ritvika is not here. Chakrika, Gauri, Hafsa.
Yes.
Okay. Next is if we are just moving towards this one. Okay. So after this experiment, when the electron was discovered, okay, so we know that atom is electrically neutral, and the scientists also know, but positively charged particle was not discovered during that time. Okay. So Thomson, according to this model, Thomson gave a model that he called plum pudding model. Okay. What he called it? What he called it? Plum pudding model. Okay. Let me uh, tell you structure of atom. Just a minute. So what he does, he gave an experiment, or we can say that he gave a model. Uh, And what is that model? That was structure of atom, and that was the first structure of atom that was given by him, and that is also called plum pudding model. Okay, and what he said according to this one, that the whole atom, if you think that it is a positively charged sphere, you can imagine that the whole atom is positively charged sphere like a ball, and electrons are embedded inside it. The negatively charged electrons are embedded inside it. Okay, understood? Are you getting my point?
Yes.
So you consider that whole atom as positively charged, then electrons are embedded inside it, and he, in order to maintain the electrical neutrality, he added in a statement that the total charge constituted by these electrons is equal to the total charge of this positive solid sphere. And he said that that's why atom is electrically neutral. Okay. Okay. So what he said, tell me what he said. J. Thomson model. In J. Thomson model state that atom is positively charged sphere in which electrons are embedded inside it, such that the total charge constituted total positive charge constituted by the atom is equal to the total charge constituted by the electron embedded inside it. Okay, got it? Got it?
Yes.
Just a minute. So write down the postulates of J. Thomson model, and there are some diagrams of J. Thomson model also. Sorry, drawbacks of the J. Thomson model. We'll discuss it later. Just a minute. Write down J. Thomson model, please. The main postulate of J. Thomson model was this one, that atom is uniformly positive sphere. Okay, electrons are embedded in this sphere, like plums in the pudding or seed in the watermelon. Electrical neutrality, he said that total positive charge is equal to total negative charge. So the of the electron, so the atom is electrically neutral. And what is limitation? He could not explain the stability, how electrons stay inside, and could not explain the result of Rutherford experiment. So note it down. Done? Done, everyone?
No. Done.
Done?
Yes.
Okay. Next one is everyone done? You, Shakrika, Other, Gauri?
Yes. Yeah. Yes.
Okay. Next one is the Rutherford experiment. Okay. Rutherford experiment was done by Rutherford, uh, but before this one, the positively charged particles was discovered, and that was new proton. Proton was discovered. Okay, the same experiment was done, and in this time, what happened is that let me explain you that how is the positively charged particle discovered. There was some changes was done. Some changes was done in the we'll say that in the cathode ray experiment. Okay, this time anode experiment. Let me show you. Okay, and this was done just a minute. Some changes was done. The pressure was more lowered and the voltage was increased in the so this type of setup was done in the anode ray experiment. Okay, here it is the positively charged, it is the battery. Okay, and this one is the perforated cathode. Here this time the perforated means that is having holes inside it. Okay, so perforated cathode was made. Okay, and when the high voltage current and is passed through it, so we see that not only the from negative to positive means not only from this negatively charged rod like in the previous one in the cathode ray experiment we see the particles are moving, but we also see that there are some particles that are moving in the opposite direction from positively charged anode, and they penetrated because it is having hole inside this is perforated cathode, so it is coming through it. Okay, and these are the positively charged particles since coming from this side to negative, and they are passing through these holes and the beams are coming. And zinc sulfide screen is a specialized screen on which the particles when strike a charged particle strike, it glitters. It glitters. Okay, it glitters. So this is the zinc sulfide screen special quality that when charged particles strike over it, it glitters. Okay, got it? समझ आया?
Yes. Yeah.
Okay, so it glitters. So this one is the uh, this one changes was done before in the cathode ray experiment. The this rod was not perforated and it was placed here, so we are not able to see anything behind it because it was not perforated. It was not having holes inside it. But this time when perforated cathode was done, so we see that not only from anode, sorry, cathode, the particles are moving. Yeah, beams are moving from negative to positive, but they are also moving from positive to negative. And when we place positively charged and negatively charged electric field, then it was doing different behavior that was done by the cathode rays. This time, in the previous one, the beams were moving towards the positively charged rod, but this time they are moving when a negative and positively charged field is produced, then they start moving towards the negative, indicating that these are positively charged rods. Okay, understood? Let you watch this video. So this is zinc fluorescent screen, and when we pass electricity to it at very low pressure, we see that these beams are moving from negative to positive. And okay, got it? Understood? And they are also carrying mass. So this is the thing that you can check it other videos also related to this one, cathode ray experiment. Okay, you can check in real life that this is the how the cathode ray tube looks like. So you can check it. This is the cathode ray tube. Okay, and when we put a magnet nearer to it, so this is the cathode ray tube, and it is moving. So this is just similar to this one. Okay. But when you bring the magnetic charge little towards it, high voltage current is passed. When he bring the negatively charged particle or magnet towards it, then it get deflected. So indicating that these beams are made up of charged particle. Got it? They are moving towards the magnet. Okay. So these are deflected. These beams are deflected by the charged particle, by the magnet. Why they are deflected? Because charged particles when move, they behave like a magnet, and magnet can exert another force on another magnet. So this is was the cathode ray that we have already discussed. And now we are talking about the anode ray experiment. So anode rays also have the same properties almost, but this time you can check the cathode ray experiment. Okay, anode ray experiment. You can check this one also. You done? You have seen? Have you seen this one? That this experiment was done that not only the charged particle but the charged particle which are coming from the positively charged anode, it can pass through the perforated cathode and can strike over it. Okay, so this is the experiment that indicate that atoms not only have the positive negatively charged particle but it also have the positively charged particles. Understood? Understood? Yes or no?
Yes.
Okay, atoms and molecule structure of atom. So please write down the properties of anode rays. Properties of anode rays. Anode rays are also called canal rays because canal means perforated cathode, because these rays passes through the perforated cathode. That's why it is also called canal rays. So anode rays or canal rays are same thing. Okay, note it down. Done?
No, sir. Done.
Done, everyone?
Yes, sir.
Okay. So the charge of electron is equal to the charge of proton, but the mass of proton is much heavier than the mass of electron. The mass of proton is 1840 times the mass of electron. So have you noted this one?
Yes.
Mass of proton is heavier. Mass of proton is heavier. Okay. And then in the next class, we're going to discuss the Rutherford experiment. Okay. So you have to keep in mind that we have to study, be prepared for it. And today we have to learn how positively charged particle was discovered and what is the properties of cathode rays and the anode rays and J.J. Thomson models and why what are the drawbacks of drawbacks of J.J. Thomson model you will be able to understand when you study the Rutherford model, because what Rutherford experiment has given, uh, it was not explained by the J.J. Thomson model. So because of that, we can say that, okay, understood? Understood, everyone?
Yes, sir.
So that's all for today. We'll meet in the next one. Thanks for coming, everyone.
Thanks.
Bye. Take care.
Thank you. Bye, sir.